Alright guys, welcome to part 2 of the Troodon Resurrection. So I got a stainless steel table, I'm going to try to put it on there. But here's a closer look at the main controls of this printer, this gigantic, massive printer. So if you didn't see the first part, this is a 400 by 400 by 500 printer. I just got done designing this 5 kilogram spool holder with ball bearings. Put all that stuff on my Thingiverse page. There's 3030 rail with the filament sensor in the back. So, alright, so got that going. So I actually did I moved the power up to the front. So I designed this little box right here, moved the power to the front, just because I'm not going to be able to reach behind there and like hit the power switch. So I took the power switch out and moved it in the front. Plus I took off these the spade connectors and I soldered them on there. That's a pretty common failure point on 3D printers, are the power spade connectors. They get hot. So, and I've actually seen, I've had to replace many melted switches and stuff just because they overheat and they're not crimped on tight enough. So they generate a lot of heat. Alright, so some of the things we're going to do this. This is that super thick heated bed. It's AC heated bed controlled by a solid state relay. That's like a power distribution board. This fan is really noisy because small fans are noisy. So I might replace that with like an 80mm fan, bigger fan. Here's the Octopus main board. And this is a MOSFET cooler here. I can't remember if I designed this or not. Maybe I can't remember if I designed this. And this was years ago. Now, I've designed many MOSFET coolers. So, not MOSFET, I mean driver coolers. Alright, so yeah, I don't think I designed this one actually. But, alright, so I'm going to do some TMC 2240 drivers. So I'm going to take out the X and Y. So right now it's all 2209s. So I'm going to replace that with some 2240s. I'm going to probably replace these motors with some speedy powers I have. And what I said earlier in the video, or in the last video, is this looks slightly different than a typical Voron. I always have trouble pronouncing that. Is that this is all machined aluminum. So like a Voron is all 3D printed plastic, all the stuff. This is all machined aluminum, so it's very rigid. It's very nice. But one thing I noticed different, I'm trying to think, I've never seen this on a Voron printer, was the X and Y is actually belt driven too. See this right here? But you're not really gaining. It's not a mechanical advantage because both the pulleys are the same tooth count. So all they're really doing is relocating the motor to a different spot. So, like I said, if there were two different size pulleys, I mean, I could actually create like a different size pulleys and create more gear reduction or something like that, but, you know, to gain like a mechanical advantage, or speed, you know, if I wanted to add more speed. So right now it's just 1-to-1, so there's no difference. So, interesting. I don't normally see that on the other printers, so that's a little bit different. So, what else am I going to do? I'm going to add a chamber thermistor. I have it just around here somewhere. Yeah, I've already 3D printed this. I designed this a while back. This little thing you can just glue it on there. So this is just basically like a typical thermistor on a hot-end thermistor. So I'm going to sticky tape it somewhere in here, somewhere in the thing, and run it down back to the main board. And that will give me, so I can figure out what the temp is inside the chamber. Fan mods. What else am I doing? Oh yeah, I have to run a new wire up to the filament runout sensor. So I mean, normally I don't run usually filament sensors on my smaller printers, just because I can't print big enough to actually kind of need one, you know. So I kind of can look at the spool and know how much filament I have, but when you're printing out pieces that this big, 400 by 400, you know, it's like you could easily run out of filament without even paying attention to it. So I'm going to do that, and oh yeah, I also have this pretty cool little. One of the issues I was having before is that because when this whole thing is put back together, I can't get to this SD card here to upgrade the MCU firmware. So it's like a remote. I still gonna mount this, but it's a remote thing for an SD card remote, so I can actually upgrade the MCU without having to take the whole printer apart. So that is pretty cool. I mean, like I said, I was trying to reach my hand in there when I upgraded the MCU firmware just a couple days ago, and it was a headache to get my hand in there. And it's actually a headache to get this heated bed off here. So I originally had drill holes just so I could get to the bottom of it. So, alright, so let me start doing some upgrades here and we'll come back. Alright, so here are the 2240s. So the only benefit of a 2240 is really you can go slightly higher voltage, a little bit more current. But what I like about them is they have an internal temp sensor or thermistor. So I can see what my X and Y are doing. So I'm only doing the X and Y, I'm not doing anything else, just the X and Y, because that's where I need the more current. Because I'm actually going to be adding slightly larger NEMA 17s, but even the 2209s would have been good enough. So I got to pull my MOSFET thing off here, or not MOSFET, the driver cooler, take two out, replace them, and then, so 2209s are UART based, whereas the 2240s are more like the 5160s. They're SPI based. So I have to go back and I have to change some jumper settings to SPI. Alright, so I think I'm almost done here. So I got the chamber temp here. Chamber temp's in the back. Now I have new LED cob lighting here. Four strips, if you can see it, all around. Got the 2240s in there. I rerouted some of the AC wire. The AC's up here in the front now. Might clean the wires up a little more. Have my little thing here for the SD card. Might need to do some tweaks here with the 2240s. The current, these are running about 1 amp. Alright, so I think it's really difficult getting the bed on this bed back on. Actually, I think it's like I don't know if I said this, but originally I think I forgot I had drilled holes to get under here where the screws are at. Yeah, this is probably one of the most difficult printers I've ever messed with to get the bed off. Let's see if this works. I wish I would have seen this, discovered this a long time ago. Versus trying to get your hand under the machine. You know, you can put it right here, reroute to the front, so you don't have to actually turn the printer upside down. So I don't have to reach behind to even turn the power button off anymore. I can just do it right from the front. Alright. I know you're supposed to shut down Linux the right way, but... and hopefully this will update. Alright, bring in some wire clips. Probably going to have to stabilize this bench. I bought this just for this printer. I mean, it barely fits on there, but I don't know if I'm going to keep this or not. But yeah, it's kind of shaky, so I might secure it in the back. 2x4s or something. So once I get that figured out, I get this thing permanently in its spot, then I'll put the case covers on. So once I get this thing thoroughly planted where I want it, and I'll put the case covers on, I'm going to do another input shaping. Yeah, because that's a 5 kilogram spool holder. Goes into that Big Tree Tech filament sensor. Right. Yeah, I don't know if I'm going to change this thing or not. You know, some things I don't really like about it, but I don't know. The wire is very messy. I mean, it's a good hot end. I mean, I don't know. I mean, Orbiter, I kind of like the XGX Lite better, but Orbiter's pretty good, I guess. I don't know. Alright, take a look. Got it. Its final spot. Got all the case covers on. So now that I have it, you know, all the case covers on, everything put back together, I'm going to do another shaper, input shaper, using the accelerometer. And then I'm also going, since I now have that thermistor in there, I'm going to do another, I'm going to see what the max ambient temperature is. Because right now I'm actually, well, in the future video, I'm probably going to be adding an active cooler. Just because I want to print out like big pieces of ABS and ESA, you know, so, but you need to have a pretty heated, for big pieces you need like a pretty heated chamber, so I'm going to put an active cooler in there. Plus you want to slowly cool it down too as well. Because if you cool it down too fast, it's going to want to warp really fast, so, you know, slowly cooling the chamber down. Alright, so I'm just curious to see, like, you know, non-active, you know, just with the heated bed going, and the hot end on, what's the max temp it will reach, just with like residual heat coming off the bed. Alright, so let's do that real fast here. Well, before that, let's do a input shaper. I actually have the home at first. Home all. So anytime I move the what's it called? I have the MOSFET, not MOSFET, the driver, stepper driver coolers come on. And now that it is homed, let's go back to macros, more macros, resonance tester. Alright, so it's going to go through this process, and then I'm going to save the configuration. Like I said, you won't, once you're in your final spot, your destination, like we're going to put it, like this actually adds a lot of rigidity to it. You know, the case covers, the sides. Alright, so I'm going to put this extruder up to 260. And make the heated bed. I mean, that's typically about 90 to 100 for ABS, ASA. Alright, so I'm going to come back. And I want to look and see if, yeah, I also have another fan that goes on. When the heated bed goes on, a fan will kick on underneath it. But I'm going to keep an eye on this. I'm going to let this sit here for like 15 minutes and see what the max temp gets here of the chamber temp here. Alright, so the max temp I'm getting on this one is probably about 90 degrees Fahrenheit, 33 degrees C, 33.5. It's pretty warm in here, but I don't know if I mentioned this, but I designed this wire cover, kind of like a shroud. Like here, this box right here. I put all this stuff on my Thingiverse page, but I couldn't stand seeing all the wires, so I covered them up. So, alright, so now that I have that big printer going, I can fully start experimenting with my high-speed printers. This one flipped upside down is the Orsinus, and the other one's the Celeritas. The Celeritas is like a quad cross XY with carbon fiber rods, 4 motors. But the Orsinus, which I designed to be crazy high-speed too, but I never really experimented with it too much of it because it was my only large format printer I had. But yeah, I have machined a big aluminum plates on there. Right now I have Speedy Powers on there. But I do actually have some Super Power HTs. But both these printers were 100% designed from scratch. I didn't copy any parts from anybody. Yeah, this one should really fly. I have the external 5160s, the Big Tree Techs on there. So these were both designed for crazy speed. So now that I have that big printer, you know, up and running, I can experiment with those things, so I don't really care if I break them, you know. I mean, they're going to be 100% experimental. They're not really for printing. They're just to test new systems and parts and techniques, high-speed printing techniques. So, alright guys, cool. Having fun. Awesome.